Good morning, students. Today we are going to start next unit, unit 8, aldehyde ketone and carboxylic acid. Student, before that, in previous unit, you have discussed about alcohol and phenol. You have discussed about alcohol and phenol and ether there. In previous unit you have discussed. In case of alcohol, there was bond between carbon and oxygen. But what type of bond was there? There was single bond. There was single bond between carbon and oxygen. In case of phenol also, if I talk about phenol, then again there was single bond between carbon and oxygen. In case of ether also, there was single bond between carbon and oxygen. Today we are going to discuss about aldehyde ketone. Today we will discuss their IUPAC name, their common name, and their derivatives. Why do we study this unit? Why we are going to study? What is importance of this unit in our life? So we will just discuss basic things of this unit today. Students, here, in case of aldehyde, in case of ketone, carboxylic acid, there will be double bond between carbon and oxygen. Between carbon and oxygen. And you know very well carbon is tetracovalent, so it will make 4 bonds. So these two groups, these will get changed. Okay, according to these groups, compound will change. Their functional group will also change. If carbon has double bond, carbon form double bond with oxygen, then commonly they are known as the carbonyl compounds. Carbonyl compounds. So basically today we will discuss about the carbonyl compounds. What do you mean by the carbonyl compounds? Carbonyl compounds are those in which carbon makes double bond with the oxygen. If carbon makes double bond with oxygen. Okay. If I talk about aldehyde, so what will happen? Here one bond will form with hydrogen. One bond of carbon will form with hydrogen and one bond with the alkyl group. Any alkyl group may be here. Any alkyl group. I am taking methyl group, you can take any other. So I can write any alkyl group here. So here, this one group, CHO group, this is known as the aldehydic group. But student, if this will be the common, carbon to oxygen, double bond will form. This will be the common. If carbon, these two bonds make with alkyl groups, make both of the bonds with alkyl group. These alkyl group may be same or may be different. Then this form is known as the ketone. This form is known as the ketone. So this one group, basically C double bond O, it is known as the ketone. If this is the common, If you are attacking, you are making one bond with alkyl group and other bond with other oxygen, and this oxygen is making one bond with the hydrogen, then this group is known as the carboxylic acid. I can write in this way also, C double bond O COOH. This is known as the carboxylic acid. And again, if I replace this H, again if I replace this H with alkyl group, so what will happen? Then they form esters. This is known as the ester. And if here one is alkyl group and one is, you can take Cl. Then this is known as the acyl chloride. This group is acyl chloride. And students, if you take one R group and one NH2 group here, one NH2, then they form amide. And if you replace this one here, this C double bond O R, here if you replace this H by again COR, this group, then they form acid anhydride. So all these are the carbonyl groups, because carbonyl group is that in which double bond form between carbon and oxygen. This group is known as the carbonyl group. So here we will see aldehyde. What is common in all these? Here common is that carbon form double bond with oxygen. In all cases it is common. So just we are going to change some groups there. In all, alkyl group is also common. Alkyl group is also common here. Okay. In case of aldehyde, in case of ketone also, in case of acid anhydride, in case of carboxylic acid also, in case of ester, acyl chloride and amide. So one alkyl group will also be common. But what is changing here? Here one group is going to change. If one bond is forming with hydrogen, then it is aldehyde. If it is further alkyl group, then they are ketone. If this is OH group, then carboxylic acid. If this is OR, then it is ester. If this is halogen, then it is acyl halide. Okay. If it is NH2, then it is amide. And if this group is COR, means it is anhydride. So these are some common carbonyl compounds. But in this unit, we will discuss about aldehyde, ketone and carboxylic acid. And we will study this unit in two parts. We will study aldehyde and ketone at same time, and then we will study the carboxylic acid. Why do we study aldehyde and ketone at the same time? Okay, because maximum almost properties of the aldehyde and ketone, they are similar property, they have similar property, they have common properties. So we will study them side by side, aldehyde and ketone in one part, and in second part we will study carboxylic acid. So students, what is the importance of the aldehyde and ketone and carboxylic acid? Basically, for fragrance they are used. For example, fragrance means if you see that some fruits, some vegetables, if they have sweet smell, means any aldehyde, ketone or carboxylic acid may be present there. Means they give fragrance, they give flavor. Like if you talk about vanilla ice cream, vanilla flower cake we use and we like that also. Okay, so what is vanilla? Vanilla, it is also known as vanillum. What is formula of this? This is vanillum. So aldehyde group is present here, you know, and because they show sweet smell, so we use them for making perfumes. Okay, for giving flavor to any food we use them. Okay, so wherever you feel sweet smell, so you can consider that any aldehyde, ketone and any carboxylic acid may be present in them. That's why they are showing. Okay, like glucose we use, so aldehyde group is present there. Like fructose we use, so fruits are sweet and fruits have some smell. We can identify if some guavas are present at our home, so from a long distance we can tell guava is present in this room or not. Why? Due to its fragrance. And some other fruits also. So here fructose, in some fruits fructose is present. Fructose is also known as the fruit sugar. And in fructose, which functional group is present there? There ketone is present there in case of the fructose. Clear to you or not? So students, now we will talk about some common names. We get some compounds from their common names in your exam. Okay, so we will see some common names which we use frequently. Okay, like if we have HCHO, it is known as the formaldehyde. If we have CH3CHO, because CHO group is aldehyde group, you have already seen that. So this is acetaldehyde. This one, cinemaldehyde. This one, benzaldehyde. You know, benzaldehyde is common name as well as IUPAC name. Okay, if IUPAC name is asked, then you will say that benzaldehyde. Benzaldehyde is common name as well as it is the IUPAC name for this. Okay, sometime we can write in this way. This is benzene. If I not include this in ring, then benzene carbaldehyde. This is benzene and 4-CHO carbaldehyde. Carbaldehyde. But students, if we talk about the IUPAC name, these are some compounds, some aldehydic compounds whose common name is asked frequently. So you will learn them. Okay. But if I talk about their IUPAC name, so we will use the suffix al. You know very well which order we will follow for giving IUPAC name. First of all, we will write secondary prefix, then primary prefix, then we will use word root, then primary suffix, and then secondary suffix. So for example, if we have this one, its common name is formaldehyde. But what is IUPAC name for this? Here, no secondary prefix. Secondary prefix like halo means chloro, bromo, iodo, methyl, methoxy, means all alkyl groups, alkoxy group. These are considered as the secondary prefix. Primary prefix for ring compounds, we use the word cyclo here, but it is not in ring, no secondary prefix is present there. Then we will see the word root. Word root means number of carbon atoms. So here carbon atoms 1, and for 1, which word root we use? We use meth. Then primary suffix are it will tell about the number of bonds. If there are a single bond between carbon and carbon, then we will use the suffix N. If there are double bond between carbon bond, we will see. We will not see bond between carbon and oxygen. We will see the bond between carbon and carbon. If bonds are double, then in. For triple bond, suffix will be ein. So all bonds are the single because I can write in this way. So here, carbon bond is single. So methane plus secondary suffix are the functional group. Here functional group is aldehydic group. For aldehydic group, we use suffix al. Okay. 2 vowels. We will not write continuously. So we will cancel this one. So what is name of this? This name is methanol. Methanol. In this way, we can give the name. Okay. If you have name like, if you have compound like this, CH3, CH2, C double bond O, CH2, C double bond O, H. So what will be the name of this compound? You know very well. 2 groups are present here. Which one group is present here? Tell me. Here 2 groups are present. One is ketone group, C double bond O, and second one is the CHO, aldehyde group. Student, if there are 2 groups present in the same compound, then you will see the preference. You will see the preferential order for the functional group. Here you will give preference to the aldehyde. Here preferential group is the aldehydic group. So second group you will consider like prefix. Okay, you know very well, you will start naming from the carbon of the functional group, carbon of the aldehyde group. You will start numbering from here. 1, 2, 3, 4, 5. Okay. So here you will consider this ketonic group C double bond O group as prefix, and for when you are using as prefix, then you will write oxo. You will write oxo. So first of all we will write the secondary prefix. So here prefix is this according to preference of the functional group. So it is 3-oxo for this group. Then no ring is there. Then word root number of carbon atoms, there are 5. So 3-oxo pent. Carbon to carbon, all bonds are single, so pentane. Okay. Then at one position aldehyde group is present here. So you need not to write one position. If aldehyde group is at second, third position, the functional group is present, then you will write. But aldehyde group will be present at first position only. Okay. So pentanal. 3-oxo pentanal. Means if 2 or more functional groups are present in same compound, then you will see the preference. Okay. One will be the preferential group and other groups you will consider like the secondary prefix. It is clear to you or not? Student, if you have like this, if you have like this, so here you will not start the numbering from this. You cannot start. Why? Because here only these 3 carbons are including in rings and it is out of the ring, and we cannot intermix carbon of the ring and carbon of the straight change. Clear to you or not? So we will keep separated. So how can we give name to this one? Here we will take this carbon first, at which functional group is attached. 1, 2, 3. So there are 3 carbon present. So how can you write cyclopropyl? Cyclopropyl. Okay. Then you will write carbaldehyde. For CHO group you can write carbaldehyde. Clear to you or not? So you will write in this way, cyclopropyl carbaldehyde. In this way you can give the name. Any doubt in this? If we talk about ketone, like if we have this one, this is our smallest, because if we take hydrogen at one side, then it will be aldehyde beta, then it will be aldehyde. So this is the smallest ketone.